Google's quantum computing team has achieved a significant milestone by demonstrating that a real scientific problem can be solved much faster on a quantum processor than on a classical supercomputer. Using their 105-qubit processor, Willow, researchers ran a demanding algorithm called quantum echoes roughly 13,000 times faster than one of the world's most powerful traditional machines. This algorithm is a meaningful scientific tool used to study how information spreads and becomes scrambled inside quantum systems, which is extremely difficult to model with conventional computers. The quantum echoes algorithm is designed to track how information flows through a system over time, which is a complex problem that has been mostly theoretical or impossible to simulate accurately with classical methods. The Google team demonstrated a technique that effectively reverses quantum operations to study these dynamics. This capability opens the door to studying complex quantum behavior that has so far been largely unexplored. The experiment showed that quantum hardware can now tackle realistic, verifiable problems rather than contrived benchmarks designed only to highlight quantum supremacy. This is a significant achievement because it demonstrates that quantum computers can outperform classical machines on meaningful scientific tasks. The team's results show that a task that would have taken a classical system more than 3 years was completed in just a few hours. The Google team used a 105-qubit processor to run the quantum echoes algorithm. Qubits are the fundamental units of quantum information, and they have the unique ability to exist in multiple states simultaneously. This property allows quantum computers to process vast amounts of information in parallel, making them potentially much faster than classical computers for certain types of calculations. The quantum echoes algorithm is a complex mathematical tool that is used to study the dynamics of quantum systems. It is designed to track how information spreads and becomes scrambled inside these systems, which is a difficult problem to solve with classical computers. The algorithm works by applying a series of quantum operations to a system and then reversing those operations to study how the system evolves over time. The Google team's experiment showed that they could use the quantum echoes algorithm to study the dynamics of a complex quantum system. They found that the algorithm ran much faster on their quantum processor than it would have on a classical supercomputer. This demonstrates that quantum computers have the potential to solve certain types of problems much faster than classical computers. Despite this breakthrough, researchers at Google emphasize that quantum computing is still in its early stages. Practical, everyday applications will require far larger systems with millions of qubits and much better error correction. Currently, quantum computers are prone to errors due to the fragile nature of qubits, which can lose their quantum properties due to interactions with their environment. However, this experiment stands as one of the clearest and most convincing demonstrations yet that quantum computers can outperform classical machines on meaningful scientific tasks. It highlights the potential of quantum computing to solve complex problems that are currently unsolvable or require an unfeasible amount of time to solve classically. The development of quantum computers has the potential to revolutionize many fields, including chemistry, materials science, and cryptography. Quantum computers can simulate complex quantum systems, which could lead to breakthroughs in fields such as materials science and chemistry. They can also factor large numbers exponentially faster than classical computers, which has significant implications for cryptography. The Google team's achievement is a significant milestone in the development of quantum computing. It demonstrates that quantum computers can solve real scientific problems much faster than classical computers. While there are still significant challenges to overcome, this experiment shows that quantum computing is a promising field that could lead to breakthroughs in many areas of science and engineering. As researchers continue to develop and improve quantum computers, we can expect to see more demonstrations of their potential. Quantum computing is a rapidly evolving field, and it will be exciting to see how it develops in the coming years. One thing is certain, quantum computing has the potential to revolutionize many areas of science and engineering, and it will be fascinating to see where it takes us. The potential applications of quantum computing are vast and varied. One of the most promising areas is in the field of materials science. Quantum computers can simulate the behavior of complex materials at the atomic level, which could lead to breakthroughs in fields such as electronics and energy storage. Another area where quantum computing could have a significant impact is in the field of chemistry. Quantum computers can simulate complex chemical reactions, which could lead to breakthroughs in fields such as drug discovery and materials science. Quantum computing could also have significant implications for cryptography. Quantum computers can factor large numbers exponentially faster than classical computers, which could potentially break many of the encryption algorithms currently in use. Despite the potential of quantum computing, there are still significant challenges to overcome. One of the biggest challenges is the development of practical quantum algorithms that can solve real-world problems. Currently, most quantum algorithms are designed to solve specific problems, and they are not yet practical for widespread use. Another challenge is the development of larger-scale quantum computers. Currently, most quantum computers are small-scale and can only perform a limited number of operations. To solve complex problems, we need to develop quantum computers with millions of qubits. In conclusion, the Google team's achievement is a significant milestone in the development of quantum computing. It demonstrates that quantum computers can solve real scientific problems much faster than classical computers. While there are still significant challenges to overcome, this experiment shows that quantum computing is a promising field that could lead to breakthroughs in many areas of science and engineering.